Hey, what's up everybody? Mark Price here at devslopes.com, and in this exciting video, we're going to be creating a game manager. Now, when you're working with games, okay, you're typically always going to have state. And what I mean is a game can have a loading screen state, it can have a is playing state, it can have a game over state. There's a certain state in which your game lives that helps know where exactly your game is. Think of any game that you've ever played, whether it's Fallout 4, when you first load the game, there's a menu, so you're in the menu state, or whether you're in the game and fighting, okay, you're in an active state, or let's say you on Fallout 4, you pull open the VAT system where he pulls the Pip-Boy up and you can target. Now you're in a targeting state, or if you're dead, you're now in a dead state. And based on the state, different events need to happen. For instance, in Fallout 4, if you die, okay, they probably want to do some cleanup on the game itself. Get rid of things that are in the background behind the characters, start unloading things that they're never going to be able to see again. And they're going to want to give us, a screen that says, "Hey, the game's over. What do you want to do now?" So everything has a state. So what I want you to do is, before we continue forward, I want you to pause the video, and I want you to think about what kind of state is in our game. What do we need to manage? What things need to stop moving? What things need to start moving? What all needs to happen in our game when it's hasn't been played yet? When the player loses? Think of all the different states. Do that right now. Come back. Write it down on a piece of paper. Okay, write all this on a piece of paper, the different things that we need to account for and the different states we need to manage. And then come back, and then we'll see how close what yours is to what we're actually going to do. Did you do it? I'm sure you didn't. You guys never listen to me anyway. I know who you are. I've been in your shoes. You guys are just rolling through the videos, not listening to me. It's all good. I'm going to pretend you did listen, though. So what I think we need to do is when the game first loads, we want our character just to be floating there, but we don't want any obstacles, right? We don't want the obstacles to interfere with the player before they've actually tapped on the screen. If you think about the Flappy Bird game that actually came out, the real old one, the 2D one, when the game hasn't started yet, he's just floating there on the screen, and there's a little image that says, tap to jump, and so you're in this type of standby state, and the obstacles aren't hitting him. The ground's moving though, and he's flapping his wings. And then when you click, then the obstacles start coming, okay? And then when you lose, okay, the ground and the objects, they stop moving from right to left, okay? And so those are some different things we need to manage. Also, we should probably turn off the ability to click the screen and jump whenever the game is over. So a few different things we need to account for. But first things first, let's create a game manager. We're going to go over to our scripts. We're going to right click, create a new C# script, and we're going to call this game manager. And I put a T in there on accident. All right, game manager. Okay, what I'm going to do is I'm going to drag this onto the camera, because I know we're always going to have a camera there. The script class cannot be found. No, okay. Oh, this is what happened. I created it with a T, and therefore in the code it had a T, but when I changed it again in Unity, it did not change it there, so therefore it threw an error. Common mistake that a lot of new people make. They're like, what's going on with my code? What's going on with Unity? If you create a script, misspell it, and then you change it there in Unity, it will not change the title of it here in the code, and you have to go and change it to the proper title. Glad we stumbled across that. Okay, so game manager, dragging on the main camera. Oh, and another good thing that you just learned is that you can't drag scripts onto objects until the compilers are gone. That's good to know too. Let's try this again. There we go. There's our game manager script. Okay, and what we're going to do is we're going to create what's called a singleton. The singleton pattern is a programming pattern where there's only one instance of it. And what I mean is, our rock here, for instance, we've got a rock script. Well, the moment that we instantiate 3 rocks, we actually have 3 scripts that are running too. So even though we only write the script once, each of those 3 scripts are running independently all at the same time. So it actually, think of it as a factory and a blueprint. The script is the blueprint, and the rock is the blueprint, and then the factory actually makes them like a car factory. So we create 3 different versions, but each is slightly different because each is in a different position. So this might be similar to a car factory producing a Ford Focus. One Ford Focus has leather seats, the other does not, and one Ford Focus you know, has an upgraded engine. Okay, I don't think they do that on Ford Focuses, but you get what I'm saying. So it's the same car 3 different times, just with some slightly different variances there. So my point is there are 3 objects or instantiations of that blueprint, or this rock in this case. But a singleton means there's only one that lives in memory at any given point in time. So when these rocks, if we destroy them out of the scene, they leave the memory. But our singleton will always live in memory until we get rid of it, and it can only have one instance of it at any given point in time. So every single thing that accesses the game manager will be going to a single point, whereas on this rock here, there's 3 different scripts. So if I wanted to reference one of these rocks, I would grab a reference to it in its script, but it would not be affecting these ones here, so I'd have to get 3 references. This may be very confusing. It's okay. You don't have to understand it just yet. It'll take time. I've talked enough, though. Let's go ahead and dive into the code here of our game manager, and let's make it so it only has one instance. So what we're going to do is we're going to create a public static variable called game manager, the same exact name as the name of your class, okay? We're going to give it a name of instance. You can call this whatever you want. Some people like to call it shared. I like to call it instance, like so. And we're going to just default set it to null. Okay. In C#, the keyword static, okay, it means that there's only one in memory, okay? So no matter who accesses it, it's accessing the exact same one. And that's what we want. We don't need 5 game managers. We only need one. And, of course, we're giving it the same type as this class because we only want one type of the game manager. Okay. And so, again, if you don't understand it, it does take some time. And don't worry about it too much. Just know that I'm steering you in the right direction here. This is what Unity actually teaches, and it's the right way to have a state in your game, or at least one of the right ways. Okay, so let's write some code here. If instance equals null, so if this awakens and it's null, then what we want to do, so we want to say instance equals this, else if instance is not equal to this, we're going to destroy this game object. We're going to do one more thing. We're going to say don't destroy on load and game object. If this looks like gobbledygook to you, it's okay. I'll do my best to explain it. But basically, if instance is null, okay, so we're holding a reference to ourselves, but remember, we only want one instance. So if somebody's accessing this game manager object, okay, it's going to become awake right here. This is going to become awakened. And then what's going to happen is we're going to check to see if it's null. If it is null, then what we're going to do is we're going to say instance is equal to this. And what is this? Okay, this is a C# keyword, and it means the current instance, okay? One instance of this class. And again, if you have any more problems or don't understand this, go search Google, how do singletons work in C#, and you can find a plethora of information. So then, else if instance is not equal to this means somebody accidentally tried creating a second object. They tried to be sneaky, but we only want one game manager. So we're going to destroy this game object, okay? So there's one of these in memory, and what we're saying here is, hey, if this instance right here is not equal to this game object that we're currently attached to, it means somebody tried to create another one, and let's destroy it, okay? And then don't destroy and load. This is a Unity function, and basically what it does is it allows a game object to persist between scenes. So if we had, let's say, 15 levels, all right, we would put this game manager in the very first level, or in the main screen actually, and then switching between levels, it would actually live between scenes. Now normally in the scene, everything is destroyed completely, unless you say don't destroy and load, and then it goes across the scenes. So we don't technically need this here because we only have one scene, but I wanted you to know about it. It's important to know. Okay, so there's our game manager. Okay, now what do we want to do? We want to know, so we know the player, things should be moving. The ground should be moving before the player even taps the screen, and the player should be floating. Well, we already know the player's floating from the default. We already set that up. So what I think we need to track here is if the player's active or player has started the game. And I'm just going to call it player active, meaning a player is not active until he's first clicked the screen. All right. So we're going to create a private variable. We're going to say private bool, and we're going to say player active equals false. We'll keep it at false by default. Okay. But then we also need to know if the game's ended. Okay. So player active wouldn't work to know if a game's ended because a player is inactive before the game starts, but a player is also inactive after the game ends. But the starting needs to do different functionality from the ending functionality. So I think we're going to need another variable here, another Boolean called game over. Okay, and that'll be triggered when the game is over. Now, why did I make these private? You know, maybe you're thinking, well, shouldn't the player just set, if the player gets hit by an object, shouldn't it just set the game over to true? Well, the answer to that is yes, but also it's no. We're going to employ defensive coding and use data encapsulation. We do not ever want another class to directly manipulate data. Okay? Static right here, the reason why this is public and static is it can't be changed. We can't change it publicly. Okay? Static is going to be a one-time thing here. Okay? And so the private ones here on these variables are going to prevent outside classes from manipulating them. And I'll show you why it's important. Let's say, just for fun, okay, let's say over here in our player, you know, we accidentally wrote the wrong code, okay? You know, over here we typed in game manager, we typed in .instance, and we said game over, right? Game over equals true. Okay, so if we directly manipulate that variable over here, where is the game manager? I didn't make it public, but if we directly manipulate that to true, we could put bad logic into it. Okay, and that's not what we want to do. We don't ever want to directly manipulate it over here. Rather, we should do something like this. We should create a function here, make it public void, and we're going to say player collided. Okay, it's very generic, but it's an event. We're saying, hey, the players collided. I just collided with something, and now you, the game manager, you figure out what to do. The player should not have to know how to end the game. The player class should just know how to manage the player class. The game manager class should know how to manage the game manager. So all that needs to happen is the player needs to say, hey, I've collided, and let the game manager know. Okay, and of course this would be a game over. Also, another one probably is public void player started game. Okay, the player doesn't need to know how to start a game. It just needs to know, hey, I clicked, I started the game, and then the game manager class then does the underlying logic here. Okay. Private bool game over. Okay, so if the player did collide, now we could say game over equals true. Okay. Now, in the future, let's say that this logic changed. Maybe we have to make sure there's a certain score. Maybe we have to make sure that this event and that event hasn't happened, and we can add to this code. If we didn't have this code here and we were doing it here, we'd have to be changing all that over here. And then if there was a different class that could end a game, let's say there's player 2 and he could end the game, that could have different code and it could be a big mess. But it's nice to have it all in one spot, especially if our logic grows. And you may not understand what I'm saying now, but over time as a developer, it will begin to make more sense. And you can always come back to this video. Okay, so player collided. Game over equals true. What about if the player started the game? Then we would say game, what is it, game active? Player active. So if the player started the game, player active is true. Okay, so data encapsulation means that you make all your variables private and that you create public functions that can manipulate that data, and you're in complete control of how the data is manipulated. Now, because these are private, our other classes have no way to access and know if the player is active or if the game is over or not. So we do need to create some public accessors, and you can do this by creating a getter or a setter, and this is all part of data encapsulation. So what we're going to do is we're going to say public bool player active, okay, and we're going to say get player active, return player active, excuse me, like so. And we'll do another one. Public bool game over. And notice how I'm capitalizing these ones, camel casing with the capital in the front though. And then I'm going to return the lowercase one, game over. Maybe you're thinking, dude, you're crazy. I don't understand what's going on here, why we're doing this. But the reason why we're doing this is because we don't want anybody to be able to modify these. So what do? We create public accessors, okay? And these are called getters or setters. Setters set and getters get. or accessors and mutators. And this is how you complete your data encapsulation. Okay, so these are private and these are public, and all you can do is get the data. You can't manipulate it, but you can retrieve it. So our player over here, or a rock or whatever, can now go in here and see if the game is over or if the player is active, but it cannot manipulate it. And then down here, it can just trigger events, and our class completely manages control of the code. This is very important stuff, and this is good code that you know, you would actually employ in a real professional game in a studio. I would validate your work if you wrote code like this. Okay, so this is looking good. We've got some base functionality here. You with me so far? I know it's a lot. I've done a lot of talking, but this is really important stuff. So let's go look at our player here. Let's handle the game over state. When should a game over happen? Well, whenever the player hits an obstacle. Okay, so down here in on collision enter, this is a perfect place to end the game. So now we could say game manager dot instance. We're grabbing that static instance variable, and then we're going to call one of those public functions, and we're going to say player collided. So we're just telling the game manager, hey, I ran into something. You handle it from here on out. Okay, this is cool, good stuff. All right, so now we've got that. Let's think of what's going to happen. So that's going to end the game, but it's not necessarily doing much of anything here. So we probably need to stop moving the platform if the game is over, and stop moving the rocks if the game is over. So let's go over here to our object script. Okay, remember our rock is inheriting from our object. Nothing should move at all if the game is over. Should the platform be moving, the ground be moving if the game is not active yet and hasn't started? Yes. The obstacles, no. But when there's a game over, nothing should move. So if game manager dot instance dot game over, and we want to do the opposite, right? So if game over equals or is not equal to true, right? Or for the shorthand, we can just put the pound sign in front. So we're saying if the game is not over, then go ahead and move the objects. Otherwise, don't move the objects. Okay? That's looking good there. So if the game is not over, go ahead and move the objects. Otherwise, don't move them. Okay. So should we see if it works? Let's go over here to our scripts. Make sure there's no errors, and let's play it. And what I think should happen is, if I hit something, all right, so that's interesting. Everything's still moving. So let's see what we did wrong here. Okay, so over here in our player, I'm sure we got a collision enter. We said player collided. So if we follow the chain of events over here to game manager and player collided, game over should be equal to true. So if we go to our object here, so if I have good logic here. So if game over is, okay, so if the game over is false, everything should move. Well, that looks like it's doing its thing. Maybe I forgot to save the file. It happens a lot. There we go. I forgot to save the file. Okay, this is interesting. Notice how the rock's not moving and the platform is not moving when I died. That's exactly what I wanted to happen. So I know that that is working. I know that the game manager is, or I know that the objects are talking to the game manager because these things stopped moving, which is exactly what we want. And I think it's okay for that to move up and down. All right, so that is working. Is there anything else we need to account for? How about when the game's over, we don't allow input to happen? So let's go back to the player. And over here, we've got this input thing. So we're going to do the same thing as we did before. We're going to say if game manager dot instance dot game over. So if only allow jumping if the game is not over. Okay. Cool. I like this. Let's take a look when I press play. Okay. Oh, wow, that's kind of cool. Look at him fly. Whoa. Okay, so what did we just do? I got distracted by the flying zombie. So our player, he hit a rock. Oh, clicking. Yeah, see how he's not grunting? So it worked. But we do have a problem. He hit the rock. I hadn't even started the game and the rock was moving. So these rocks need to not move when the player is not active. We don't want those objects to move yet. So for the rock here, what I think I want to do is not call the update, the move function on it in this rock until the game is active. So if game manager dot instance dot player active, that's the one. So if the player is active, let's go ahead and move the rocks. Otherwise, just let them sit there until it's time. Okay. And then I think what we need to do is in the player here is when they first click, or when they click here, then we set the player to active anytime they click. That means the game started. So game manager dot instance dot player started game. And let's go ahead and run it and see what happens. As you can see, the rocks are not moving to the left, so this will continue on forever. This is just like Flappy Bird. The ground's moving, but the obstacles are not coming. Not until I click to jump. Notice how they're moving now. This is perfect. Ding, ding, ding. Okay. And the game stopped. This is really cool. So we're now managing game state. The platform stopped, the rock stopped, the creature fell to the ground. And basically at this point, we can now present the game over user interface. And do you want to play again? Really cool stuff. So I know we've covered a lot in this video. Okay, we've talked about singletons. We've talked about data encapsulation in those singletons, or just in general, making variables private, but then creating public accessors. And I typically give the variables a lowercase camel case here, and then the public ones, uppercase, like player active. And then we expose our functions publicly. And these are usually just some type of functions or actions, right? You do something. So we're saying, hey, the player collided or the player started the game. And then our game manager class here manages this and this. It would have been bad if player was directly setting game over and things like that. It should not have to know how to end the game. It should just emit events. And wow, a lot of this is coming together here. So we implemented some game logic based on the state of a game. And every game has state, okay? And the actions of the objects in the game are usually always going to be based on the current state. So watch this video again if you're confused, but we're making great progress. We're going to end now. Mark Price at devslopes.com, moving on and forward.